so thanks for coming. I assume if you're here, or that's because you might have heard in the past few months some voice saying maybe Verkle is should be replaced with stacked binary trees. And the purpose of this presentation is to give you some arguments to understand why now is not the right time to do this. Let's briefly go over the current status of Verkle trees, the Verkle tree implementation in Ethereum. We launched a DevNet two weeks ago. It's chugging along fine. We have something that is pretty close to the final spec. We're missing a couple of gas costs here and there, but nothing that won't be fixed by the next DevNet. And you can go have a look at this address. It will be displayed again at the end. One of the biggest things we achieved during the last year was a Holesky shadow fork. We validated that the transition model works. So we're really proud of that, and big shout out to DevOps for helping us through this, because that was quite something. And yes, the elephant has landed. That's because the spirit animal of the stateless fork is the elephant. We simplified and clarified, so there was a big work of simplification, clarification of the gas cost EIP. So Verkle is split into two EIPs. One of them is 4762, the gas cost. They pertain to stateless, and then there's 6800, which is the pure description of the tree. So we had a lot of questions about it. It caused a lot of corner cases. We addressed all of that. So I'm not going to say it's completely ready, because we still need to take into account EOF 7702, and I'm sure a billion things that will come in the next two forks. But it's looking pretty advanced and pretty mature at this point. We also implemented the execution spec test framework. So until now, when we wanted to make sure clients agree that we don't have any consensus bugs, we used to launch a testnet and verify. But now we don't even have to do this. We just have tests that target a specific use case. So big shout out to Ignacio and of course the testing team for working on this one, because we found countless bugs before we even had to launch. So yeah, that was also a great progress this year. And then there's been experiments in implementing Verkle-friendly sync. So this one was actually done by Nethermind, by Tanishq and Nethermind, and it's the first full feature that has been implemented in that hasn't first been implemented in Guess. So big shout out to Tanishq again. Right, and the last thing that we achieved last year was the state expiry. There was an EIP that was published by Han. He did a very good presentation this morning about it. So if you haven't seen it, I suggest you go and watch it. But just to give you a quick rundown, the idea is that Verkle trees are pooling their leaves together by groups of 256. And then they have some kind of extension stem on top of it, and the commitment, which commits to the orange box, which is the commitment. What we do is we add a new field that used to be 0, and now it's the epoch number, so it's backwards compatible. It's really good. And when you want to delete some data, you just delete the whole 266 values, and you just keep the commitment. And because everything is polynomial based, you can provide a proof of the entire subtree. So you have to resurrect the whole subtree in one go, but it's great because effectively you only keep the internal nodes, and the internal nodes is where Verkle trees especially shine. This is what takes the less space in the whole thing. So it will provide a state expiry scheme that is efficient, that is pretty much turnkey. We could activate on it on day one of Verkle, and yes, it's very simple in the sense you don't need address space extension, you don't need to do any modification. It's really working out of the box. So the conclusion is that after 4 years, Verkle is pretty much ready for its prime. Of course, I'm not going to pretend it's ready to ship tomorrow. We still have a couple things to do, but I think within a year will be you know, a year of focused work. Of course, we could be ready to ship. Let's go over the pros and cons of Verkle for the rest of this discussion. The first pro is that if you take the Verkle proof and the Verkle witness, this is really small, and this is like much smaller than any alternative you can think of. We had several experiments, and we found some encoding that is especially efficient, so it's known as type 3 here. The average size is like 400 kilobytes, less than 400 kilobytes, and the worst case that we observed, so we replayed historical blocks. Caveat, of course, they did not, because they're historical block, they didn't have the whole Verkle gas cost activated, but it's still a very interesting reference. What we see is that the worst case is less than 1 megabyte. The theoretical worst case is 3 megabytes, but on average it's less than 400 kilobytes, which is really good because you've probably have heard about increasing the gas limit, increasing the blob count. All of this is going to have an impact on the bandwidth. So the fact we have a very efficient proof structure, something that like we will add some size, but adding very little compared to any other option is definitely a plus. The trees itself is small. It's like on average from measurements we've made, so we take an MPT, we convert it to Verkle, and we see what the end result is. It's about 25% smaller. We have optimizations where we could shave yet another maybe 20 gigabytes still. But more importantly, it's also changing the way we store the data, so you can write to the DB more efficiently, at least the guest DB. This is my reference. So this is something that's very useful. One of the really good things about Verkle, or at least stateless, actually, it's not even just Verkle, but you can immediately join the network when you want to sync. And then you can download the data you're missing. If you want to build a full node, you can download the data you're missing in the background. But unlike the current experience where you just wait for the blocks to be downloaded and then the state, and then you hope that you've got everything in order to be able to follow the chain. You start following the chain right off the bat, and only then do you worry about downloading the data. So if you want to compare the idea of a Verkle sync to the current state of SnapSync, what happens in SnapSync is that you start downloading the state here, I'm using sprouts because I want to point out that the data at this stage is fresh. It's the latest data you've got. But as blocks keep being added to the chain, the node keeps downloading data, but the old data, like the data that was downloaded before, is actually becoming stale. So this is represented by dried leaves. So what you have to do is go to the network and ask nodes that are synced to send you the data that is obsolete and update it and keep it fresh. But while you do this, of course, the chain keeps advancing, so the data is, some other part of the data is becoming obsolete, and as a result, you need to hope that this dance and this communication can go fast enough that you can hope to sync up to the head of the chain in a reasonable time. This is the problem that might hit us at some point, especially if we stress the chain with increasing the gas limit, like lowering the block time, whatever. There's a few things that can happen that will make this even more difficult. With Verkle Sync, you have what I call the instant heal, because the block contains extra data here that is a proof plus the pre-state. And the pre-state is everything you need to execute the block. So as you download the data, here it's sparse, but it could be linear, it doesn't matter. You have the same problem of what you have becoming stale, but at the same time, all the data that you need to heal the state you've got, the stale state, is already provided in the block. So you can immediately heal it, you don't have to go over the network. So that makes for a much faster sync. and eventually you get the whole data downloaded, and that's it. So now there's a point that Verkle is not perfect. There's no quantum resistance, especially well, in two places really: the proof computation and the balancing of the tree. You could craft keys that in such a way that the tree would be unbalanced, which is really computation would make recomputing the state root computation intensive. Another issue with Verkle trees is that even though they've been designed to be ZK friendly, they're not the most efficient structure for the latest and greatest of ZK technology, as I call it, however you want. So there are a bunch of potential fixes. One of them is that, at least for the tree unbalancing, you could simply use a regular hash, and that problem would be solved. It would also make Verkle trees much faster, because the Pedersen hashing is one of the biggest waste of time. Speaking of time, I'm getting a bit late, so I'm going to skip the rest of this slide and switch and go on to binary trees. So there are good things about binary trees. It's quantum secure. I mean, at least if you use the correct hash function. The hash functions are faster, and it does play nice with all the fancy new ZK tech, especially Starks like Circle Starks, Benius, whatever. The bad part is that unless you do have proper performance, which might happen soon if Poseidon is fast enough, for example, but if it's not, we are still a bit wanting in this respect, then you will have to use just binary Merkle proofs. This is not very good, because it will make proofs much bigger. Even if you activate ZK, well, sorry, not ZK, but Starks, if you use binary trees with Starks, what you will get is a proof plus witness that is at least twice as big as the Verkle proof. So we were talking about bandwidth. This will have a cost. Like, there's a trade-off here. And then the tree, because there are more nodes, the tree will be significantly larger. So caveat here, we're working on some encoding that might not make it as true as what I just stated, but this is like the current state of the state of the art. That I might change my tune in a week or two, but currently this is a fact. And it doesn't solve what I call the sync race issue. You still need to ask someone to provide you with a proof, maybe a start proof. This is quite computationally intensive to provide, so the problem still remains. Okay, let's get to the big question. Should we skip Verkle and go straight to binary trees? So that was, to be clear, that was always the goal, right? Verkle trees are here in the middle. It's the big blue square. But if you look at later, there's quantum like the end game, I would call, is the quantum safe Starks. This, like stepping over Verkle would, has a few assumptions. The first thing is that the end game remains the same. We don't decide to add more features, or we don't decide to go in another direction. Maybe you've heard about beam chain. There was a direction that was given, and all of a sudden we're talking about changing directions. This has always been the case in Ethereum. Since I've been in part of the community. So this is extremely likely that the end game will change. It also assumes that like, the argument is always, well, we will have to do two transitions instead of one. This is the least likely to be true of all these assumptions, because right now you want to have binary trees with Starks in the hope that the technology that you use will be the one that you can use to start the entire block execution, not just the tree root computation. But because you deliver this in two steps, there will be something new coming up that will maybe not play as nicely with the technology you chose to compute the tree root. So I would say there's a big question mark here. And also, what if you could find, and the research has barely started on this, and is also not as active as it should be. But theoretically, you could find a way to do a ZK-friendly, ZK and quantum-resistant Verkle tree. It also assumes, oh, sorry, I went a bit fast. It assumes that Poseidon is secure. Like the Ethereum Foundation is about to create some kind of grant to try to break Poseidon, because Poseidon did not get enough scrutiny. And then also there's a big question of whether or not we want to be able, or what do we do, for example, if producing a star proof in an acceptable time can only be done in big data centers. Do we turn our backs on the Ethereum ethos of solo block building and solo block proving? This is a big question to have. So there's a lot of political. There's also a political dimension for this. And then, yeah, like I revealed before, there's also this tweet proves that there's a lot of innovation in ZK right now. Or at least tree proving, state proving. The one technology that we're talking about right now will be obsolete in 6 months. So it might make sense to just take it easy, wait for this frenzy to stabilize a bit, and then make the decision. Yes, well, there's of course the quantum computing risk. There seems to be a kind of a moral panic right now about quantum computing. I am a skeptic, I'm not gonna hide this, but yeah, your guess is as good as mine. Should we panic about something that might not ever exist? Yeah, we don't really understand decoherence. Is it possible to to have as many qubits as would be needed to fake a Verkle proof? Well, I don't know. The future will tell us. So yeah, one of the problems also with this question of skipping Verkle is you are effectively comparing something that is ready to ship, quasi ready to ship, with something that is quite undefined. So there's still a huge specification work that needs to be done and has barely started. We don't know what the exact structure of the binary tree would be. We don't know what the witness would look like. Does it contain all the state diffs? This is being answered as, well, maybe not as we speak, but this is being debated, and we need to reach a conclusion, but we haven't so far. Is Poseidon secure? If Poseidon is not secure, well, we need to go to SHA-256. This is much harder to prove in a circuit. Which is a proving system? This is what I was saying before. We need to make sure that that we have the best technology for the job. And yeah, there's also a question of values. Do we want to only build blocks and prove blocks in data centers, or do we want to do on a Raspberry Pi? Surely the answer is somewhere in the middle, but it needs to be discussed and agreed upon. Let me add to that point that the more uncertainty you add, the more delays you add, because questions need to be answered, those questions I just mentioned. And you have the choice between the imperfect technology that you can have now and the perfect technology that never will be. Yeah, there will always be an improvement. In fact, what happens to Verkle right now will happen to binary trees where start. There will be something better. Verkle displaced binary trees without start, so it's definitely going to happen. In my view, done is better than perfect. And I would say Ethereum has a history. So for those who don't know, I was with Mikhail Kalinin and Danny Ryan. I built the first prototype to do the merge. The exact same thing happened. There were lots of ideas, but nothing was being delivered. So we sat down, we designed a very simple engine API. Done was better than perfect. Ethereum advanced. And I think the problem of Ethereum right now is that it doesn't make those leaps. It keeps living in that future and toying with a lot of ideas that will never happen. Right now, Verkle exists, Verkle is there, it's the strongest value, it's the only value proposition at this stage. So we I think it makes sense to keep working on it, but to be clear, Verkle has been, or at least stateless has been built with upgradability, reusability in mind. So we will change the tree structure, but the gas cost would not change. The state conversion would not change, like all those methods have been validated. The historical root contract, like 2935, could be used. State expiry, to be confirmed, but should be reusable verbatim as well. So that's, yeah, that's reassuring, I think. We can afford to push the question of binary trees to a time where it's more defined. That's pretty much it. Go check verkle.info to have all the news, and Kaustin and testnet to check our latest testnet. Come break it, help us build it. Yep.
Thank you for the wonderful talk, Guillaume. Let's turn our attention to questions. If Ethereum also adopts Verkle, should rollups also adopt it?
Yeah, that's a good question. They are good. I mean, it's always a question of maintaining a diff. So if you think that, so yeah, there's this thing called rollup Geth that tries to be a fork of Geth and maintain a standard base. Maybe rollup Geth could implement binary trees if they want, but should they? I mean, I don't know. Are you interested in a smaller disk footprint, small proofs, and something that's readily available? I'd say, yeah. I'm not gonna tell rollups what to do. I'm saying I think it's also a strong value proposition for rollups.
How do Verkle trees help with stateless clients?
I mean, it's a technology that it basically makes very small proofs. So you can attach it to the block, and as a result, stateless clients just download one block, and they're following. They're considered to be following the chain. That it's completely secure. So that's their power.
Are there any major trade-offs of Verkle trees over Merkle-Patricia tries?
It's a bit. It's like maybe an order of magnitude. It's still very fast, but it's slower to compute a root commitment in Verkle trees. So blocks tend to be a bit slower to build.
Okay. How do Verkle trees generate O1 proofs?
By the magic of, how would I say that? So yes, because I know, the question is probably because we use IPA, and IPA is logarithmic, but it's logarithmic on a constant vector, so it's effectively O1 proof. If you want some details, we can talk about this after the talk.
How would a quantum attack work on Verkle? Is it important to consider quantum resistance?
It's only important if quantum computers are real. How would an attack work on Verkle? Yeah, I skimmed a bit over it. You could either unbalance the tree, but that's easy to fix, or you could create fake proofs. In that case, what would happen is that all the stateless clients would accept a block, and all the stateful clients would realize that the proof is completely nonsense and would reject the block. So the network would split. That comes at a cost, of course, because obviously if quantum computers happen, then Verkle is off the table. We're not doing that anymore. But the question is, what happens if no one knows you have a quantum computer? In that case, you would reveal, you would show your deck to everybody. And the result of doing this would be that you would be a nuisance to Ethereum for a couple days, but then everybody would just go back to having stateful clients. So, yeah, that would be a usability drop, potentially, a big headache for core developers, but ultimately that's a big price to pay to just annoy a few people.
What about legacy data if Verkle trees are adopted on mainnet?
The whole thing is converted, so nothing is lost.
Okay. What's your opinion regarding the post by Vitalik to wait longer and do more research into ZK instead of doing Verkle trees soon?
The whole presentation is my answer. But to be fair, Vitalik, is more like it's an idea. It's not like he's hardcore decided on it. I have a screenshot that says Verkle might be the last thing that we do that is not quantum resistant.
Well, the next one's more of a command than a question, but stop delaying Verkle and ship it instead of other non-urgent features. Would you like to comment on?
No. I think people know my opinion. That's enough has been said.
Okay, great. And how does PCS multi-proof with random evaluation work on Verkle trees? I tried hard, but I'm too stupid to understand. Crymoji ×2.
Yeah, it's quite hard. We can definitely explain, just maybe not in 37 seconds.
Okay, and as a last one, what is your take on the bandwidth disk trade-off?
I think, well, bandwidth is going to be the biggest resource in the future, just my personal opinion. So whatever makes improves the bandwidth requirement is a good thing. Disk is also a good thing, but I think at this point Verkle is going to come too late to prevent the switch to requiring a 4 terabyte hard drive.
All right, that's it for questions. Thank you very much.